Our instructions here are still perform the indicated operation, and I know this looks a little fuzzy, it's not copying real well, but this actually is a division problem. It might look a little bit like an addition problem, but actually it's division. This is a division sign right here. So remember, when we're doing a division problem, we always have to flip the second fraction, not the first one, but we flip the second fraction. So I'm going to rewrite it with the fraction flipped. So I have 3x squared plus 2x divided by 9x squared minus 4. Now times 9x squared minus 6x plus 4 divided by 27x cubed, hard to see that, but it's a cubed, plus 8. Okay, so we're going to start over at our first fraction and the numerator and look for a GCF. I have one. It's x, which leaves me 3x plus 2. And in the denominator, I don't have a GCF, but this is a difference of two perfect squares, which remember factors to the sum and difference of the roots. So that makes it 3x plus 2 times a quantity 3x minus 2. And now I'm looking at 9x squared minus 6x plus 4. I'm looking to see, since there's no GCF, if there's anything that will multiply to 36 and add to negative 6. Well, if nothing's coming to mind, think of all your factors of 36. I have 1 in 36. I have 2 in 18. I have 3 and 12. I have 4 and 9. I have 6 and 6. Those are all my factors of 36. And regardless of whether I make positives or negatives, because of, well, actually, if they're multiplying to a positive, they have to either both be positive or both be negative. Since they're adding to a negative, they would have to both be negative, and there's no combination here that would give me negative 6, which means that polynomial is prime. So I just write it down the way I had it, 9x squared minus 6x plus 4, and this denominator is a sum of cubes. So again, a sum of cubes, we take the cubic root of the first one, that's 3x, the same sign, that's plus the cubic root of the last one is 2, and now ignore that, we're finished with it, we go down here, square the first one, that's 9x squared, first times last, but first, opposite sign, first times last, 6x, always a positive sign, square the last, that's 4. Again, that was cubic root of the first, the same sign, cubic root of the last. Now look here, square the first, an opposite sign, first times last, a positive sign, square the last. So now everything is factored, and I'm looking for what's alike in the numerator and denominator that I can divide out. Well, you notice this 9x squared minus 6x plus 4 cancels with that one. You'll often find that happening in these kinds of problems where you have a sum of cubes, that you had something that wouldn't factor in your either numerator or denominator, whichever was the other one, that allows you to cancel out. Okay, here I have a 3x plus 2. I'm left with, in my numerator, an x, and in my denominator, 3x minus 2 times 3x plus 2. Now you notice I put the minus 1 before the plus 1. Does it make any difference? The answer to that is no, because multiplication is commutative. I can put these in either order. Now, if I have a monomial and then a binomial, I like my monomial first, but if they're both the same length, they can go in either order. Okay, now we have another division problem. Again, a little bit hard to see on the page, but this is a division problem. So I'm going to rewrite the first one, x squared minus 8x minus 48. Whoops, didn't mean to put that parenthesis there, but we'll go ahead and put it in both places. Over 7x squared minus 42x. Those parentheses in the numerator were not necessary. Okay, I'm going to flip the second one because that's what we do when we're dividing. We change it to multiplication by flipping the second one. So that means my numerator now is x squared minus 10x plus 24 over my denominator is x squared minus 16. So now I need to factor everything. I look at this left numerator. I'm looking for what multiplies to negative 48 and adds to negative 8, which would be negative 12 and positive 4. Remember, when they multiply to a negative, you have one positive and one negative, and if they add to a negative, it means your bigger choice was the negative one. So that factors to x minus 12 times x plus 4. Remember, FOIL it if you're not sure if your answer is right. Okay, over, this is a binomial with a GCF. My GCF is 7x, and that leaves me x minus 6. Okay, here I'm factoring one with no leading coefficient, or of course we know that really means a leading coefficient of 1. So I'm looking for what multiplies to 24 and adds to negative 10. It multiplies to a positive and adds to a negative, which means they're both negative, and my numbers are negative 6 and negative 4. So that gives me x minus 6 times x minus 4. And in my denominator, that's a difference of squares, so it multiplies to the sum and difference of their roots, which is x plus 4 times x minus 4. So now that everything's factored, I'm looking for what is alike on the top and bottom. I have a common x minus 4. I have a common x plus 4. I have a common x minus 6. And I believe I have divided out everything that I could, which leaves me x minus 12 in the numerator and 7x in the denominator. And of course, because I have no factors up here, these are each a term in this binomial, I cannot cancel those x's because the x in the bottom is a factor, the x in the numerator is not. So that's my final answer for that.